these are the targets 8 and 9 homework worksheets. And we're going to be doing matrices again, adding and subtracting in target 8, a little bit of solving as well. And then target 9 is going to be multiplying. So let's see, let's start with target 8. If we can recall what a matrix is, it's just an array of numbers. We can state the dimensions of a matrix by telling how many rows by how many columns it has. So let's go ahead and check, because we know that when we add and subtract matrices, they have to have the same exact dimensions. Now that's a little bit different when we multiply, but when we add and subtract, they have to be the same. So in number 1, this first matrix is a 1, 2, 3, 4 by 1. And then my second one is a 1, 2, 3, 4 by 1. Now, you don't have to do that every time. You don't have to write it out and, take your pencil and write out how many rows and stuff, but it is helpful. But when you're adding and subtracting, most of the time it's pretty easy to tell if they're the same dimensions. Like those two look exactly the same. They have exactly the same amount of numbers in exactly the same spots. So yes, you can add them or subtract them. And number 2, same thing. Those are all 3 by 2 matrices, so we can add those. Okay, I'm going to erase this because I need to see my numbers here. And I'm going to start in number 1 by doing a little bit of highlighting like I did in the notes. I'm not going to do this for every single one of them because it takes a lot of time, but I'll just kind of show you what I'm doing here. So I'm taking 3 and 6 and subtracting those. Take a new color, 1 and -2, and I'm subtracting those. Then I take -4 and -1, and I subtract those, and then I take -3 and 5, and I subtract those. So you look at the first matrix and you pick a number. The number in the second matrix that's in the same exact position is the one that you add or subtract to that. And my result, or my answer, is going to be a matrix of the exact same dimensions every time. So it's going to look exactly the same. So -3 minus 6 gets me a -9. 1 minus a -2, or 1 plus 2, gives me 3. -4 minus a -1, or -4 plus 1, gives me -3. And then -3 minus 5 is -8. And that's my answer for that one. Alright, now in number 2, I'm not going to highlight like I did. That would take a lot of time. But I will go ahead and mark with my pen what numbers I'm actually adding or subtracting together. So since all of these are 1, 2, 3 by 2, 1, 2, 3 by 2, and then 1, 2, 3 by 2. Like I said when we were doing number 1, yes, we can go ahead and add these or subtract these together. The result is going to be the exact same dimensions. It's going to be a 3 by 2 matrix. So I'm first taking my top left position. -3 plus 3 minus 4. -3 plus 3 is 0, and 0 minus 4 gives me -4. Then I'm going to move down. Now you can move to the right if you'd like, but I'm going ahead and move down. -2 plus 2 minus 0. Well, -2 plus 2 is 0, and 0 minus 0 gives us 0. -2 plus a -2, -4. That's what it gives me. Minus a -2. So -4 minus a -2, or -4 plus 2, gives me -2. -2 plus 0 minus a -2. So -2 plus 0 gives me -2. And then -2 minus a -2, or -2 plus 2, gives me 0. If it's helpful for you to write out exactly what you're doing, like instead of doing this the shortened way that I'm doing it, if you want to do 1 plus 6 minus a -4 and put 1 plus 6 minus a -4, instead of writing exactly what it means automatically, that's fine. Take that extra step if that's going to help you. I'm just going to do this in my head because I don't have that much room, but you can by all means do that step. So 1 plus 6 gives me 7, and then when I subtract a -4, I'm just adding 4, so that gives me 11. And then finally, -3 plus 1 minus a -4. So -3 plus 1 is -2, and then -2 minus a -4, -2 plus 4 gives me 2. And that's my answer. Okay, let's move on. Number 3. So if you look carefully here, let's look at the first matrix. It's one row, but it's 1, 2, 3, 4 columns. So this is a 1 by 4. On the right, still one row. Kind of hard to see there. Hang on a second. Let me erase that. All right, so then y minus 1 is one term. So one row and then 1, 2, 3, 4 columns. All right, well, they're the same dimensions, which means I can add them. So let's go ahead and do that. I'm going to erase all of that because it's blocking me. Okay. My result is going to be a matrix of the same size. Now, because I have variables in this one, I'm going to go ahead and take an extra step to kind of see if any of them can be combined and stuff like that, because that might happen. So I'm taking y plus y squared minus 4y. Oops. I didn't mean to write that so high. All right, y plus y squared minus 4y. I'm going to switch colors because they're all going to run together. Then I'm going to take 4x and subtract negative 4. Whoops, 4x minus negative 4. That's just going to be 4x plus 4. Back to red. xy minus y minus 1. Minus. Now don't forget, if you're subtracting an entire expression like y minus 1, you have to put it in parentheses. So minus y minus 1. I'm going to have to distribute that negative sign to both terms there. And then finally I have y squared minus 4x. Right, well, these actually can be simplified just a little bit. So in the first one, I have y plus y squared minus 4y. So y minus 4y can be combined to be negative 3y, and then I have that plus y squared. So negative 3y plus y squared would be my answer there. And then my next one, 4x minus a negative 4, that's just 4x plus 4. Then my next one, xy minus y plus 1. I have to distribute that negative sign. So xy minus y plus 1. None of that can be combined. I'm just going to leave it as that. And then my last one, y squared minus 4x, those can't be combined either, so I'm just going to leave them. And this would be your final answer in blue. All right, number 4. Let's see. My order of operations tells me that I need to do whatever in the parentheses first, PEMDAS, P-E-M-D-A-S. So parentheses is first, so I need to actually add those two matrices first. But let's see if we can actually add them. So we have 1, 2, 3 rows and 1 column, so this is a 3 by 1. And this is only a 2 by 2. Well, those aren't the same dimensions, so this can't even be possible. We can't even add or subtract anything in number 4. So number 4 is just undefined. If you find yourself unable to add or subtract or solve or multiply or anything like that, always just write the word undefined. That is your answer. Okay, let's move on to number 5. It says solve each equation. So we're going to use our solving skills here. Oh my god, I just dropped my pen. Okay, solve each equation. So I'm going to solve for x in number 5. I'm going to get x all by itself. Well, 3 times x, to get rid of that, I'm actually going to divide by 3. So when I do division, and I'm dividing, or multiplying in that case, a matrix by any one number, like 3, or 4, or 2, or 1, or anything like that, all I'm doing is taking that matrix, every term in that matrix, and multiplying or dividing by that number. So I'm going to take negative 9 and divide it by 3, and then I'm going to take 18 and divide it by 3, and then I'm going to take negative 6 and divide it by 3. So I get, as my answer, x equals this new matrix of the same size. Negative 3, 6, and negative 2. Alright, number 6. To get y by itself here, I'm going to add this matrix, 6, 4, 4. To the one on the right. So those cancel. And I'm left with y equals some matrix of the same size. I'm going to take each term and add it to each term. So negative 2 plus 6 gives me 4. 0 plus 4 gives me 4. Negative 5 plus 4 gives me negative 1. And that is my final answer. Okay, then I'll flip it to the back, and we're going to target 9 homework now. Now, this is where it gets a little bit longer. I have to do multiplication here. So, let's see. Number 1, it says simplify and then write undefined for expressions that are undefined. So if we can't do them, we're just going to put undefined. So in number 1, all it's asking me to do is take 3 and multiply it by that matrix. So I'm taking every term in that matrix and multiplying it by 3. So my answer is going to be a matrix of the same size. In this case, 3 by 3. I'm sorry, not 3 by 3. 1 by 3. Only one row, 3 columns. So 3 times negative 4 gives me negative 12. 3 times negative 2 gives me negative 6. And then 3 times negative 1 gives me negative 3. Essentially what I did was just distribute that 3 to all terms. Let's do number 2. Same thing, essentially. I'm multiplying that matrix by one number, so I'm distributing 2 to all terms. My answer is going to be another 2 by 2 matrix. So I get negative 12, 8, 2, and then 10. That's my answer. All right. A on number 3, essentially the same thing. I'm taking matrix A and I'm multiplying by 3, so I'm distributing to all terms. My answer is going to be another 2 by 2 matrix. So 6, negative 6, 33, and then negative 15. All right. And then on B, I actually have to do matrix multiplication. Let's see if those matrices can be even multiplied at all. So this one right here is a 2 by 2. This one here is a 2 by 2. Let's check. Is 2 the same number as 2? Yes. Which means my result is going to be a 2 by 2 matrix. Result is a 2 by 2 matrix. That will always tell you if you can multiply and what the resulting matrix is going to look like. Okay. I'm going to erase all of this so that I can see what I'm working with here. Okay. So first I'm taking the first row in my first matrix and the first column in my second one. When you're multiplying matrices together, don't forget, you're always working with the rows in the first matrix and the columns in the second matrix. So I'm taking 2 times 1 and adding that to 11 times negative 1. So 2 times 1 gives me 2. And then 11 times negative 1 is negative 11, so I'm essentially subtracting 11 here. Alright, let's move on to the second column in the second one. I'm taking 2 times 7, and I'm adding that to 11 times 3. So 2 times 7 gives me 14, and then 11 times 3 gives me 33. Now, I moved over to the right in this case. If you want to go down, you can, but it's easier when you're multiplying to stay with the same row, do both columns, and then move on to the second row and then do both columns, if that makes sense. Alright, so this is as long as my matrix is going to be. I can go close that. My only thing left is to work with that second row in my first matrix and then do both columns in my second matrix. So I have this row, I'm taking this column first. So 2 times 1 multiplied by, adding that to negative 5 times negative 1. So negative 2 times 1 gives me negative 2. Negative 5 times 1, negative 5 times negative 1 gives me positive 5. So I'm adding 5. Getting tongue-tied over here. Now I'm moving on to my second column. 2 times 7, and I'm going to add that to negative 5 times 3. Negative 2 times 7 gives me negative 14. And then negative 5 times 3 gives me negative 15, so I'm essentially subtracting 15 here. Alright, so I'm almost finished I actually just have to do that math inside there. 2 minus 11 gives me negative 9. I'm going down. Negative 2 plus 5 gives me 3. 14 and 33 gives me 37. I'm sorry, 47. That was weird. These matrices make me tired. 47. Okay. And then negative 14 minus 15 gives me negative 29. Alright. There we go. Okay. Simplify. Write undefined for expressions that are undefined. Now, unfortunately, there is not a lot of room on this paper. So if you want to go ahead and do your work on a separate sheet, that's totally fine. Just make sure you attach it to your homework so that we can see that you actually did the work. But yeah, that's totally fine. There's not a lot of room here. Okay, let's go ahead and do number 4. So can we multiply these? Let us check. 2 rows by 3 columns. So 2 by 3. And then 3 rows by 2 columns. All right. Is 3 the same number as 3? Yes, it is. Our result is going to be a 2 by 2 matrix. That's our resulting answer matrix. It's going to be that big, 2 by 2. So really not that big, smaller than both those. All right, I'm going to erase all of that now. You know it's going to be 2 by 2. Start way over here. First, I'm taking this row, multiplying it by this column. Now, we haven't done one of these yet, where we have 3 different terms to add, but it's going to be that we're treating it the exact same way. So we're taking 5 times negative 1, adding that to 2 times negative 2, and then adding that to negative 5 times 0. So 5 times negative 1 gives me negative 5. 2 times negative 2 gives me negative 4. And then negative 5 times 0 gives me 0. All right. Whoops. Ow, didn't mean to do that. Okay, I guess I'm just going to erase it. I thought I could move it, but I can't. Same row in my first column, moving on to this first row in my first matrix, moving on to the second column in my second matrix. All right, 5 times 6, 2 times 6, and then negative 5 times 1. All right, so I'm moving over to the right. I didn't go down yet. I'm moving to the right. So 5 times 6 gives me 30. 2 times 6 gives me 12. Negative 5 times 1 gives me negative 5. That's as far or as wide as my matrix is going to be. All right, let's move on to the next row. So now I'm working with this row right here. Let's do this first column. I'm taking 5 times negative 1. Then I'm taking negative 3 times negative 2. Then I'm doing 3 times 0 and adding all this together. So 5 times negative 1 gives me negative 5. Negative 3 times negative 2 gives me positive 6. And then 3 times 0 gives me 0. Anything times 0 gives me 0. Finally, second row, second column. 5 times 6. Negative 3 times 6. And then 3 times 1. So 5 times 6 gives me 30. Negative 3 times 6 gives me negative 18. And then 3 times 1 gives me 3. No, not exactly done yet. I have to write those out now. So top left, negative 5 minus 4 plus 0 gives me negative 9. I'm moving down this time. Negative 5 plus 6 plus 0 gives me 1. 30 plus 12 minus 5, so 42 minus 5 gives me 37. And then 30 minus 18 is 12, plus 3 is 15. That is my answer. Final. All right, number 5. Let's see if I can multiply those together. The first one is 2 by 2. This one is 1 by 2. Let's see here. Are 2 and 1 the same number? No, they are not. So The answer to number 5 is actually just undefined. Saves us a little bit of work there. All right, number 6. Can we multiply these? Let us see. 1 by 2, 2 by 3. I can already see that, yes, I can multiply those matrices together because those two middle numbers are the same. And my result is a 1 by 3 matrix. All right, so it's going to be kind of small. It's going to look like, oh, not that big. Only one row but 3 columns. So it's going to be like a line of numbers. All right, I'm going to erase all of that just so I can see. Okay. Taking only the one row that we have in the first matrix, and I'm multiplying that by every column that I have on the right. So I'm taking -6 times -4, then I'm taking -1 times 1, and adding those together. So let's actually move this up a bit, sorry. -6 times -4 gives me 24, and then -1 times 1 gives me -1. Alright, let's move on to the next column, -2 and -6. So -6 times -2, and then -1 times -6. -6 times -2 gives me 12, and then -1 times -6 gives me 6. And then finally, the third column. I'm taking -6 times -1, and I'm taking -1 times 5. So -6 times -1 is -6, and then -1 times 5 is -5. Alright, so I actually have to do that now. My final answer is 23, 18, and -11. Oh wait, I'm sorry. Goodness. That should have been a +6 minus 5. -6 times -1 is a +6 minus 5. So that should just be a 1. There's my answer. Sorry about that. Alright, finally, I'm going to section off number 7 because I feel like I'm getting a little hectic here. Give me some room for number 7. Alright, we have a 2 by 2 times a 2 by 2. And yeah, I can multiply those. 2 and 2 are the same number. And my result is a 2 by 2 matrix. Perfect. I'm set. I can go ahead and start. I'm going to erase all that. Alright. First, I'm looking at the first row and the first column. Let's do -6 times -5, and then 1 times -1. So I have +30 minus 1. Move on to my second column. -6 times -6, and then 1 times +6. So I get positive. Oh my goodness. Alright, 36 plus 6. Let's move on to my second row. I'll do my first and second columns. Let's see. -1 times -5, and then -1 times -1. -1 times -5 is +5, and -1 times -1 is +1. Finally, my second column. -1 times -6, and I'm adding that to -1 times 6. So I have positive 6 minus 6. Alright, let's do that math. 30 minus 1 is 29. 36 plus 6 is 42. 5 plus 1 is 6, and 6 minus 6 is 0. Phew! Okay, finally I am done. That is multiplying matrices.